Okay, yesterday we went over this briefly. NASU, right? The N stands for needed. Everybody needs 8, except for hydrogen. It only needs how many? 2. So it's either going to be 8 or 2 that we're going to put inside in that column there or in that row. Available deals with the total number of valence electrons. So you look at what column it's in. Hydrogen would be 1. The second column, the alkali earth metals, would be 2. Then we jump over to where aluminum's at, 3, 4, 5, 6, 7, 8. You can't have more than 8. We skip the transition metals. Then shared, we're going to find that by using this formula, needed minus available. And the unshared, we're going to find using this formula. The most trouble everybody has is with the needed and available. We seem to kind of get them mixed up a little bit. So when we're working problems later on today, kind of think about that. Go slowly. We said yesterday carbon is always going to be the central atom. And if it's not the central atom, we're going to put the one that's the least electronegative. So I'm going to put carbon in the middle. I'm going to put a hydrogen on each side and an oxygen above. Now, when you're setting these up, the thing I want you to think about, anytime I have a central atom, we talk about there being 8 valence electrons around it, right? So when we're putting attachments on it, we usually put them perpendicular. Like we put an H here and an H here and an O here. We try to set that up so they're always perpendicular. Okay, it just makes things flow a lot easier. It works out real well. So that's pretty much how I have this one set up. So we focus in a little bit, bring this in a little closer. For our needed, everybody needs 8. Carbon needs 8. Oxygen needs 8. Each of these hydrogens need 2, right? 8, 8, 2, 2 for a total of 20. Under the available, we look at the column, the group or family it's in. Carbon would have 4 valence electrons. Our oxygen has 6, and each of these hydrogens need only 1. So you might go and be looking at your periodic table to know where I get that from, because that seems to be a common problem. I add them up to get 20. I add available up to get 12. And all I do after that is to take 20 minus 12, which gives me 8 shared, and then my 12 minus 8 for my unshared. So all we're trying to do is come up with a good methodical approach to where to put the electrons. And after you've done them 5, 6 times, you'll start to see a pattern. Things get a little bit easier. Okay, but at the beginning, it can be a little confusing. So let's put our shared in. In order for them to be shared, they have to be put between the atoms. So I'm going to put 2 between this carbon and this hydrogen. And I'm going to put 2 between this carbon and this hydrogen. Well, Well, you only need, hydrogen only needs 2. I can't put any more here. It's already got its fill. So I have 4 left out of these 8. So the only place I can put those 4 is between carbon and oxygen. If they're going to be shared, they have to be put between those 2. I've used up all 8 of these. They're done. Well, what about my 4 unshared? Well, if we look at this hydrogen, it has 2. It can't take any more, right? And we look at that hydrogen, it's 2. I can't give it any more. And if we look at carbon, if I cover all those up, how many does it have already? 8. So I can't give carbon anymore. It's got its fill. So the only one that gets any more electrons is oxygen, because it only has 4 of them there. So it needs 4 more. Well, guess what? I have 4 unshared, and so I'm going to give it my 4 unshared electrons. So now it does have its 8. Okay? And you could rewrite that if you wanted with lines. You could have wrote the double bond. So we We can do it like this if that's what you would like to do as you're placing them. Either way is fine. Okay? Questions on that? Okay, let's come up with a couple other examples, and then we'll let you get cranked up here. Let's try CF4. So I'll kind of, there, go to the side there. Carbon, we said, is always in the middle. So I'll put a carbon here. Again, I'm going to try to put these all perpendicular to each other. I put my 4 F's around it. And then I start the math part. Needed. Everybody needs 8. There is no hydrogens here, so everybody needs 8. So I have 8 plus 8 plus 8 plus 8 plus 8, because I have 5 different atoms. We add that up. It's a total of 40. Available. This is the one that we have troubles with. Carbon. We look at it on the periodic table. How many does it have? 4. And each of the fluorines have 7. When I add that up, it's 28 plus 4, it's 32. Like I said, those are the 2 places that we have some troubles with. Now my shared is 40 minus 32, which is 8. And then my unshared is just my A minus S, so it's 32 minus 8. And that's going to be 24. So let's put them in. Always take care of your shared first. I have 8 shared, and I'm going to distribute them around the carbon, and I've used all 8 of them up. I have 24 unshared electrons. Well, I cannot give carbon anymore. It's already got its 8. So we'll just start placing them. Now that fluorine has 8, so I use 2, 4, 6. We'll put another 6 around this fluorine, so it has 8. We'll put another 6 around this fluorine. That's a total of 18 of my unshared, right? They're not being shared, they're not between atoms. And I'll put the last 6 down here. One way that you should almost always check available is 32. I cannot have more than 32 dots out here. Usually when we have this many, it's not a problem. But I might see somewhere where somebody's got like 26 dots and they're only supposed to have 13 or 14 or something like that. It's like you can't, this says I only get 32 of them, okay? I might have to move them around or put them someplace else, but I can't just keep adding dots until I make it what I want it to be. So be careful of that. Okay, and then the last one, let's try a polyatomic ion. We'll try SO4. Got a -2 charge. So which one do you think would be in the middle? Just looking at it. Sulfur, right? I mean, it's alone, it's all by itself, right? So sulfur, and then again, we put our 4 oxygens around the outside. I wish this was a lot more different than it is, but it works out. My N, again, I have 1, 2, 3, 4, 5 different atoms. They each need 8. For a total of 40, right? You okay with that? I know I'm going fast, but available. Well, sulfur and oxygen are in the same family. How many valence electrons do they have? 6. So we do 6 plus 6 plus 6 plus 6 plus 6 plus, if you looked at this note up here, which I'm sure most of us didn't, if it's a polyatomic cation or anion, we add or subtract based on the charge. Well, it has a -2 charge. Did it gain electrons or lose electrons? It gained. That's why it became negative. Electrons are negative. So we have to give it. It has 2 extra electrons available. So when we add that up, it becomes 32. So this 2 came because it has a charge on it. So my shared, again, 40 minus 32. My unshared, again, is A minus S. So it's, oops, sorry. It's going to be 32 minus 8. Gives me 24 again. I know it's the same numbers as what we just had over there. So I'm going to put my 8 shared electrons. And then I'm going to place my 24 around here. And it kind of helps explain why SO4 has a -2 charge, because otherwise it wouldn't fit together very well. And in reality, what you really are supposed to do is put a square bracket around these and show a, I know I didn't give much room, a -2 under. That's really the proper way to draw that when you're done. Okay. Otherwise, if you just write a -2 out there, it's floating around in space. Nobody knows what it's attached to, that kind of thing. Okay, that's it. So you've got a list down here to practice on.